Hi, what is a student? A student is a processor. Why do I say that? Because today in our education we learn to them to process. So here is why. We give them a problem. We ask them to extract the data from this problem, to choose an algorithm, and to apply it. Then they get some output and they have to formalize it. So this is how a student works. Understanding the problem. That doesn't mean understanding, that means being able to extract the data. So the second step is to choose the function to apply to this data. So this is simply a mapping. Mapping of what? Mapping of kind of problem with kind of algorithm. Then they have to formalize the output. Simply they take, if we are speaking about animals, they will speak about animals, etc. So these are simple steps and it doesn't involve too much thinking. One example is optimization problem. Most students that are in high grades will tell you that for optimization problem you use derivative, but this is completely wrong because you use derivative for some of them, but they are unable to see that you can use something else because we make some drill and we tell if you have optimization derivative. So also some student doesn't understand what they are doing, so they write some good symbols, but they don't know what this is. But they know that if they saw this and this, they have to write this because it's in their formula sheet that they have to study. But they don't know what they have done. They have done an integrals. That's it, points. They have done an integrals, but they don't know what is it. So they can't build on integrals because they don't know what this is. So how could they build on something they don't know what is it? So this is a black box. If x enter, then x squared over 2 is the output. So this is how today's student works. So here is an example that I will solve 3 times using 3 methods to show you 3 kinds of students. The last one is punished all the time. So first student will do the multiplication. So the problem is simply multiplication. So sorry, it's an habit. So up 1 0. I could put already 2, 3 and 4. I do that to avoid mistake. So 4 times 5 is 20. 3 times 5 is 15. 2 times 5 is 10. And 1 times 5 is 5. And 5, 2, 7, 1, 6. So this is traditional algorithm that permit us to do multiplication and to be sure about the result. So why I did put the 0 at first? It's because here, as you see, there is 2 0, and if you don't pay attention to it, you could put 3 0 here because you see 2 here, so you add 1, 3, 4, etc. So you propagate an inattention error. So this is why I did it first put the 0. So it will always work and the answer should be always good. Now the same problem. seen by another student. 1, 2, 3, 4, 5. So we have to multiply it by 10, by 5. So it's like multiplication by 10, then division by 2. And so we make 6 times, up, 1 time, sorry, 2, 1 time, then here 7 time, so this 2 times, and this 5 times. So here we have a small shortcut, because multiplication by 10 is simply adding a 0, and then division by 2 is easy. So we have an easier problem. And now the last student that will do the same problem. So it's time 5, so it's time 10. And now let's look at the number by itself, if it has some specific properties that we can use. Yes, of course, or I will not show the example. Take the the digits 2 by 2, and you will see that each pair of digits is even. That means that that there is no report in the division process, so we can simply do the division, so that way, and we have the answer. And you can see that this is less error prone than the first and second method, and this is a lot faster, but we had to make a little reasoning. So it's not a direct method, it's not we have some input data, we choose one general method and we apply it. Now we have some input data, we analyze the input, we see that there is some properties, and we build something on that properties to speed up the process, because we exploit these properties. This is what we have done. We have, in the first step, we have taken a standard algorithm. So if I have to multiply by 5, first I add a 0 and then I divide by 2. But for the division by 2, we took a shortcut, because we noticed that the number has properties that we can exploit for the division by 2. So we didn't rely to a already made algorithm, but make our own algorithm. And this is what is powerful, and this is what we have to learn to students. We have to learn to them to create algorithms and to analyze the input before processing it, and to find their own way if they feel that it will be faster. So we have to make them practice this art. Thank you for listening.